continuation. Concept of neutralization. We know equivalent weight concept, equivalent weight of acids, equivalent weight of bases, equivalent weight of salts also. Okay, see, when we add an acid and base, in generally what we will get a neutral solution, right? But sometimes we will get acidic solution, sometimes we will get a basic solution, depends upon the given data. Not always a neutral solution formation takes place, that is not mandatory. Sometimes we will get acidic, sometimes we will get a basic solution, and sometimes we will get a neutral solution. Okay, let us see the condition. When you get the word how much amount of acid is required to neutralize base, then use this condition, neutralization condition. Okay, see the condition, gram equivalence of acid is equal to gram equivalence of base. This is the condition of neutralization. During numericals, if you observe this condition, immediately use this relation. Gn of acid is equal to Gn of base. Right. In the last class you learnt about normality. What is normality? Normality is equal to number of gram equivalents by volume. See this. Normality is equal to Gen, number of gram equivalents by volume. From this, Gen is equal to normality into volume in liter. Here also liter unit. Okay. So what is Gen? What is Gen? Gen is equal to normality into volume in liters of acid is equal to normality into volume in liter of base. We can expand the Gn. Next, see, Gen is equal to, you know what is number of moles formula? Number of moles is equal to weight by gram molecular weight. Number of gram equivalents is equal to weight by gram equivalent weight. Weight by gram equivalent weight. So in place of Gn, what you can write? Weight by gram equivalent weight. Okay, see this, weight by gram equivalent weight of acid. Here also you can write weight by gram equivalent weight of base. Why? Because Gn is equal to weight by gram equivalent weight. Different relations are there. So based on the given data, you have to select which formula we have to use. For example, if one compound data is given in terms of weights, other compound data is given in terms of volume. For example, if acid data is given in terms of volume and base data is given in terms of weight, then take like this. Normality into volume in ml divided by 1000 is equal to weight by gram equivalent weight of base. This is also important. Just we are converting Gen into different forms. Okay, what is Gen here? N into V. You wrote N into V only. Next, what is Gen? Weight by gram equivalent weight. You are not learning any new formula, just you are converting Gen. Already you learnt all these in the normality concept. Clear? Remember these four formulas. When you get the question, concept of neutralization. Okay. So when acid data is given in terms of volume and base data you have to find in terms of weight, then fourth formula. You know, Gen is equal to weight by gram equivalent weight. So I kept weight by gram equivalent weight. If data of acid is given in terms of volume, so take this in the volume. In ml, you have to keep 1000 in the denominator. Okay. What is the condition of neutralization? Gn of acid is equal to Gn of base. Let us see one model question, then you can understand. In physical chemistry, it is better to discuss the model question immediately, then you will get the concept. Okay. Completed. And once revise n factor concept. What is n factor for acid? N factor nothing but basicity, number of H plus ions released by an acid is called as n factor. In case of oxyacids of phosphorus, what is n factor? Number of oxygens minus 1 is the n factor. Clear? What is n factor for bases? Number of OH minus ions released. N factor for base is nothing but number of OH minus ions released. Clear? Let us do one question. Find the volume of 0.2 molar calcium hydroxide solution to neutralize 0.1 molar 10 ml H2SO4 solution. This is the question. The volume of 0.2 molar calcium hydroxide solution to neutralize 0.1 molar 10 ml sulfuric acid solution. So neutralization word. So immediately what you have to use? Gn of acid is equal to Gn of base. And this is very important model in the solution chapter also. Second year physical, first chapter. First part is concentration terms only. So indirectly you are doing solutions questions. Okay. You tell me condition of neutralization is? Gn of acid is equal to Gn of base. Gn means N into V of acid is equal to N into V of base. But where is normality? Normality is not given here, right? What is given to us? Molarity is given. Molarity data is given. Once look at this. Which data you need? Normality data. In condition of neutralization, normality concentration term is there. But what is given to us? Molarity. So what we have to do? First convert this molarity into normality. So divide the solution into two columns. First one side take base data, other side take acid data, right? What is its molarity? 0.2 molarity. And what is its N factor? Calcium hydroxide dissociates into Ca plus 2 and 2 OH minus. Okay. And N factor is 2 because it is releasing 2 OH minus ions. N factor in case of base is number of OH minus ions released. So calculate normality. What is the relation between normality and molarity? Normality is equal to N factor into molarity. What is N factor 2 and what is molarity? 0.2. That is equal to 0.4. So normality is 0.4. And what about volume? You have to calculate the volume, question mark. Volume, question mark. Here molarity is 0.1. You know sulfuric acid, directly I am writing N factor for sulfuric acid is 2. Why? Because it gives 2 H plus ions. So normality is equal to N factor into molarity. N factor 2 into 0.1, that is equal to 0.2. And volume is already given to us here. What is the volume? Volume 10 ml. Right? Now use the condition of neutralization. Condition of neutralization. Gn of acid is equal to Gn of base. right? And GN means N into V of acid is equal to N into V of base. N into V of base. Okay, right. What is normality of acid? Acid related data. What is normality? 0.2. Volume is 10. Here, what is volume? Volume in liters or milliliters? In the formula, according to the formula. See this. But why I didn't convert? Why I didn't convert? Because both sides I have to convert. So just you take the volume directly. While doing the concept of neutralization questions, you no need to convert it into ml. You can take the given volume directly. Here n how much given? How much we got? 0.4 into V, volume of base. Calculate this. So V is equal to 0.2 by 0.4 into 10. That is equal to 5 ml. Second question. How much weight of sodium hydroxide is required to neutralize 0.2 molar (20 ml) HCl solution. See, did you observe the data? One compound data is in weights, other compound data is in volumes. Molarity is common, weight volume concept. Volume and related to sodium hydroxide weight is asked, right? What is the condition of neutralization? Gn of acid is equal to Gn of base. Based on the given data, take one compound in terms of volume, other compound in terms of weight. First of all, write the data related to the two. NaOH, here HCl. NaOH data, nothing is given. Weight we have to calculate. What is gram molecular weight? Sodium hydroxide gram molecular weight, I said to by heart, 40. Then gram equivalent weight is equal to, what is gram equivalent weight? You know, gram equivalent weight, gram molecular weight by acidity. 40 by what is acidity of NaOH? NaOH release how many OH minus ions? 1. So its equivalent weight and molecular weight both are same. Okay, right. Weight you have to calculate. Gram molecular weight is fixed. Generally we have to remember gram molecular weight. HCl data. HCl molarity is 0.2. Then what about normality? N factor into molarity. N factor for HCl, how many H plus ions it gives? 1. So 1 into 0.2, that is equal to 0.2. And volume is 20 ml. Now, first of all, write the condition. Gen of acid is equal to Gen of base. Based on the given data, you have to convert this. Acid data, in acid volume term is there, na? So write this in terms of volume. N into volume in ml by 1000. When volume is given, this is the formula. And base should be calculated in terms of weight. Weight by gram equivalent weight. So the fourth formula. This is also important model. Okay, right. N, what is N? 0.2 into volume 20 divided by 1000 is equal to weight you have to calculate. Gram equivalent weight is 40. 0.16. 1 6 gram. So two models I given to you, basic idea. Okay, you know gram equivalent weight concepts. In the last class you learnt about equivalent weights. Okay, concept of neutralization. See, molarity is over, normality is over. Next keep heading molality. Mole fraction, continuation. Symbol of molality is small m. Molality. The number of moles of solute present in 1 kg of the solvent is called as molality. The number of moles of solute present in 1 kg of the solvent. See, molality is equal to number of moles by weight of solvent in kilogram. Molality. In molality definitions, is solvent term will come, not solution, solvent term. Okay, number of moles of solute present in 1 kg of the solvent. So molality is equal to, in place of n, what you can write? Weight by gram molecular weight into, see here kg is there, so if you write 1000 here, you can take weight of solvent in grams. So in place of n, weight by gram molecular weight, we are converting kg to kilogram. So 1000 by weight of the solvent in grams. See, in molality all are weights only, na? Is there any volume term? No. It is temperature dependent or independent? Independent. Is there any volume term? No. So it is temperature independent. So best preferred concentration term is molality. In molarity, normality, volume terms are there. So volume will change with the temperature. So we won't get some accurate values during experiments related to high temperatures. Okay, so the best preferred concentration term is molality. You have so many concentration terms, but which term you prefer? Molality. Why? There is no volume term. Best preferred concentration term. It is temperature independent, and the units also we can write. What are the units? Mole by kg. So mole kg inverse. Mole by kg. Mole kg inverse. Temperature dependency. Temperature independent concentration term. Temperature independent. Temperature independent concentration term. And best preferred concentration term. Write that also. Best preferred concentration term. Best preferred concentration term. Write one important relation. Relation between small m and capital M. Relation between small m and capital M. Any idea? Molality. Small m is equal to molarity into 1000 by density into 1000 minus molarity into gram molecular weight. Sometimes you will get direct questions in the NEET based on the formula. If you know density, if you know molarity, you can find molality. Okay? What is M here? Capital M is molarity. D stands for density. GMW is gram molecular weight. Gram molecular weight. A molal solution. A molal solution means molality is equal to 1. A molal solution. Two molal solution means molality is equal to 2. Basic level question first. Find the molality of 1.8 grams of glucose present in 2 kgs of water. Very simple question. Write the data. First of all, given data. What is given to us? Weight of glucose. Weight of glucose is 1.8 grams. And what about gram molecular weight of glucose? Glucose gram molecular weight 180 grams. So formula and weight of, just a second, weight of water. Weight of water is 2 kilogram. Convert it into grams, 2000 grams. So molality is equal to weight by gram molecular weight into 1000 by weight of solvent in grams. So substitute weight 1.8 divided by 180 into 1000 by weight of the solvent 2000. So, see, do you have any doubts in this decimal points, zeros? Give the answer for this. Girls, say the answer. One. Okay, whether it is correct or wrong, you respond. Okay, that is, response is very important. If you get wrong answer, nothing will happen. Shruti? 1 by 2. 5 into 10 to the power minus 3. 1 by 2 means that only. 1 by 2 into 0.1. 5 into 10 to the power minus 3. Okay, let us see. 3 zeros get cancelled. Remove pointer and keep 10. After point, one digit is there, so by 10. Here what is remaining? 1 by 2 is remaining. These two will get cancelled. So here 1 0 and here 1 0. So 1 by 100 means 10 power minus 2. 10 power minus 2 into 1 by 2. 1 by 2 means 0 0.5. 0 0.5 into 10 power minus 3.
Nice.
Okay, minus 2. And finally 5 into 10 to the power of minus 3. This is basic level question to understand the formula and the data conversion.
Sir, it mole per kg and mole per gram.
kg only. According to definition. Next question. Find the molality of 20%. Let us just a second take the data, easy data. %% W by W NaOH solution. Find the molality of 10% W by W NaOH solution. Molality. You know notations. Advait, what is the meaning for this notation? Can you say? 10 grams of NaOH in 100 grams of solution. But you tell me to calculate molality, what we required? Weight of solvent or solution according to the definition? Solvent. How to get solvent weight? I given already in the. So 10% W by W NaOH solution means 10 grams of NaOH. Weight of NaOH is 10 grams. Present in 100 grams of solution. 100 grams. Okay. Then weight of solvent is equal to 100 minus 10. That is equal to 90 grams. Weight of solvent is 90. Then you can find. So molality is equal to weight by gram molecular weight into 1000 by weight of solvent. Weight of solvent in grams. 10 by gram molecular weight of sulfuric acid 40. 1000 by weight of solvent is 90. How to simplify this? See. Zero, zero. Okay. 5 times and 2 times. So this is 5 into 10, 50 by 18. 50 by 18. Again we can write like this, not 25 by 9. 25 by 9. 2.7. How much will get?
2.07.
2.07. So 2 approximately. Find the molality of 10 molar sulfuric acid solution having density 1.02 gram per ml. Find the molality of 10 molar sulfuric acid solution having density 1.02 gram per ml. What is the formula related to molality and molarity? First of all, write the data. Capital M is equal to 10, density is equal to 1.02. Okay, so molality is equal to molarity into 1000 by density into 1000 minus molarity into gram molecular weight. Simplification part is important. See, sometimes you can take approximate data.
1000.
Density into 1000. Okay, sorry. Write the data. Molarity 10 into 1000 divided by density 1.02 into 1000 minus molarity 10 into gram molecular weight of sulfuric acid is 98. In the numerator 10,000. 10,000 divided by what about this value? Tell me. 1020. 1020. How you will get 1020 here? 1.02 into 1000. See, this can be written like this, no? These two zeros will get cancelled. This one and this one. See this part. So sorry. 1020 minus this is 980. 10,000 divided by 10,020 minus 980 means how much? 40. 10,000 by 40, these two zeros will get cancelled, right? 1000 by 4. 1000 by 4 means 250. 250 m. Mole fraction. Symbol for mole fraction is chi. How to pronounce it? Chi. But generally we read it as a x. X. One is curved line, one is straight line. Chi. Let us take a box. In that 4 balls and 3 bats. 4 balls and 3 bats are present in a box. Number of balls, or let us take number of moles of balls. How many? 3. Number of bats, how many bats are there? How many? 4. So total moles is 7. Total 7 moles are there. Here I wrote, okay. Total is 7. Now you tell me what I am writing here. 4 by 7 means, what is this value? 4 by 7 and 3 by 7 means? This is the ratio. Ratio of what? Number of moles of balls by total moles. Number of moles of bats by total. That is only mole fraction. Mole fraction is the ratio between number of moles of one component to total moles of all the components. Mole fraction is nothing but number of moles of one component to total moles of all the components. Okay, right. Now this is represented like this. Mole fraction of, this is say bats, this is mole fraction of balls. Number of moles of balls by total moles. Number of moles of bats by total moles. Right? So it is defined like this. It is the ratio between number of moles of one component to total moles of all the components. Note down Na by Na plus Nb and Na by Na plus Nb. What you will get here? Na plus
NB.
Nb by Na plus Nb. After addition, you will get 1. Important relation. So what you can write in place of, sorry, xa can be written as 1 minus xb. Similarly, xb can be written as 1 minus xa. Correct only, no? We use this in the Rolle's law in solutions. Xa plus xb is equal to 1. So xa is equal to, send xb that side, 1 minus xb. Clear? Do this question. A sample of air contains 64 grams of O2 and 56 grams of N2. Find the mole fraction of O2. To calculate mole fraction, what we required? This side write data related to O2, this side write data related to N2. How much weight is given? 64. What is gram molecular weight of oxygen? 32. 16 plus 16, 32. So number of moles of O2 is equal to, that is equal to 2. Here weight is equal to 56. Gram molecular weight is equal to 28. Number of moles of N2, weight by gram molecular weight, 56 by 20. Here also weight by gram molecular weight only I used. Weight by gram molecular weight. So here 2. What is the formula for mole fraction? Mole fraction of O2 is equal to number of moles of O2 by number of moles of O2 plus number of moles of N2. That is equal to 2 by 2 plus 2. That is equal to 2 by 4. That is 1 by 2. Or 0.5. One idea only actually. Okay. In NEET level question, this is the one part. If you know how to calculate a mole fraction, then only you can get the total question. You won't get this much easy question, but in NEET level or JEE level, if you know how to find mole fraction, then you can get the total question. Do this question. The mole fraction of glucose in a binary solution is 0.2. Find the mole fraction of water. Mole fraction of what is given to you? Mole fraction of glucose is given to you. Mole fraction of glucose is given to you. What you have to calculate? Mole fraction of water. What is the relation? Mole fraction of glucose plus mole fraction of water. Sum of the mole fractions is equal to always unity. This is 0.2. So mole fraction of water is equal to 1 minus 0.2, that is equal to 0.8. All these are basics actually. Simple questions never means these much basic level questions never come, but we use this relation. Okay. In Raoult's law, solutions chapter. Next, parts per million, ppm. Last term, ppm. Parts per million. Parts per million, ppm. See, when the amount of solute is very less, means in 1 liter, if we add some 1 gram salt, that is very less, right? Very dilute, minute, tracer quantity. In 1 liter water or 500 ml water, if you drop 1 gram salt, that is negligible only, very dilute, tracer quantities. When solute is present in tracer quantities, we use concentration term ppm. We have several concentration terms, molarity, normality, molality. But when we use ppm term, when amount of solute is very less in tracer amounts, okay, for 1 liter if 1 gram is present, then we can use ppm, right? Note, mention that if amount of solute is in tracer quantities, we use ppm. Parts per million. Formula for ppm, parts per million is equal to weight of solute in grams divided by weight of solution into 10 to the power 6. Okay, note down. Keep heading. Stoichiometric calculations. Stoichiometric calculations. See, before going to start stoichiometric calculations, learn some equations from decomposition equations and oxidation reactions also. You know how to balance the equations, general methods. Note down some important reactions before starting the numerical part. Basic and fundamental equation CaCO3. Upon dissociation, it gives CaO and CO2. You should know this. Sometimes you won't get this equation. Okay. NaHCO3, what is its name? Sodium bicarbonate. Sodium bicarbonate. Na2CO3 plus CO2 plus H2O. We can write 2 here. See, this is also important equation. When we combust hydrocarbon, what are the products? Always CO2 plus H2O, fixed. When you combust any hydrocarbon, what are the products? Carbon dioxide and water. What is oxygens? No, I am going to do that only. See, commonly we will get carbon dioxide plus water. Any hydrocarbon, ethane, methane, propane, benzene, anything will produce CO2 and H2O. After that you have to balance. After balancing only start the question. Clear? Now balancing, that's why I asked random balancing. I think everyone knows about random balancing method. Here how many hydrogens are there? 4. So keep 2 here. This side how many oxygens are there? Now you tell me. How many oxygens are there this side? 2 here. 2 here. Total how many? 2 into, see, if any number is present, that number belongs to all the atoms. Clear? So just imagine the bracket. 2 into oxygens, 2 oxygens. So this side how many are there? 4. So this side 4 should be present. So write 2 here. Okay? Like benzene. Same procedure. Balancing is same. Because if you know balancing, then only you can get the questions. Stoichiometry based questions are important in the numericals. And some other reactions also. Look at this. Ag2CO3. What is its name? What is its name? Silver carbonate. 2Ag plus CO2 plus half O2. Note down this also. Sometimes you won't get the equations. You have to write the equations by your own. And this reaction is known by everyone, I think. Very famous. Tell me. AgCl. AgCl precipitate. AgCl plus NaNO3. NaNO3. Aluminium plus oxygen. I am writing here Al2O3. Can you say the complete stoichiometric equation? Aluminium plus O2 gives rise to product is Al2O3. Balance that.
4A plus 3O2 gives us.
Yeah. See, this side 2 aluminiums are there. Here 1 aluminium. 2 oxygens, 3 oxygens. See, when you get one side even, one side odd, in that case multiply, cross multiplication. See, 2 is there na, into 2 into 3, cross multiplication. 2 into 3 6, 3 into 2 6 over, next to 2 into 2 4. So here 4 aluminium. Shall I test you? Basics. 1 mole of CaCO3 weight. Weight of 1 mole of CaCO3. 1 mole of any substance weight is equal to 1 mole of any substance weight is equal to its gram molecular weight. It's gram molecular weight. 1 mole of any gas occupies how much volume? 22.4 liter. Clear? Right. What is our heading? Stoichiometric calculations. We have several types of calculations. See, first mole calculations. Mole calculations. Weight calculations. Weight calculations. Third one, weight volume calculations. And volume, if you know above 3, then volume is very easy, you no need to discuss separately. Mole calculations, weight volume, and volume calculations. Let us start first. Mole calculation is very easy. And see, these all 4 categories are useful in other physical chapters also. Basics in every physical, most of the chapters, like solutions, kinetics, electrochemistry, ionic equilibrium, thermodynamics, we use all these. First question. Find the number of moles of oxygen required. Number of moles of oxygen required to get 3 moles of SO2. Finding the number of moles of oxygen required to get 3 moles of SO2 from sulfur. Look at this. Number of moles of oxygen required to get 3 moles of SO2. What is the reaction? S plus O2 gives rise to SO2. First of all, see how to write the moles. Moles nothing but a coefficients in the reaction. What is the coefficient here? 1. 1 mole of sulfur. Here 1 mole of oxygen. 1 mole. Right? So question is related between these two. For 1 mole, how many moles of SO2 will come? 1. To get 3 moles, how many moles you have to take? 3. Cross multiplication. For 1 mole, you are getting 1 mole of SO2. To get 3 moles of SO2, how many moles you have to take? Do cross multiplication. X into 1 is equal to 1 into 3. That is equal to 3 moles. Okay, right. Completed. Be habituated for the cross multiplications. For these many moles, these moles are produced, like for 1 mole, 2 mole, for 4 moles, how many? How to write moles? Mole relation. Mole relation is nothing but a coefficients only. Coefficients, numbers in front of reactants and products are coefficients. I'll give you one question on that. Right. How many moles of next question? Basics. All these are basics. Actually, we didn't start a neat level. First of all, I'll give the basics. Then we will go with the neat level. Next question, how many moles of O2 is produced when 1 mole of KClO3 is heated? How many moles of O2 is produced when 1 mole of KClO3 is heated? First of all, you should know the equation of KClO3 decomposition. KClO3 decomposes into 2KCl plus 3O2. This is the equation. 2KClO3 gives rise to 2KCl plus 3O2. You have to remember this. Okay, remember by heart. Remember this equation. Before that, I given some 6 or 7 equations and this one also. KClO3 decomposition. What is its name? Potassium chlorate. Potassium chlorate decomposition also important. Potassium chlorate. Who will give the answer? Answer is 3 moles.
1.5.
How many moles of O2 is produced when 1 mole of KClO3 is heated? Mole relation. 1 by 2. 3 by 2. Now don't get confusion. See, first of all, write a mole relation according to the stoichiometric equation. How many moles of KClO3? 2 moles. This is standard equation. And how many moles of KCl? 2 moles. 2 moles of KCl. And how many moles of O2 is produced? 3 moles. Now question is related between KClO3 and O2. So take these two only. Ignore other one. Now see, when you heat 2 moles of KClO3, how many moles of oxygen is producing? 3. But to get 1 mole of oxygen, if you take 1 mole of KClO3, how many moles of oxygen is produced? If you take 2 moles, you are getting 3. If you take 1 mole, half, 1.5. For 2 moles, how many moles of oxygen is producing? 3. But in the question, how many moles of KClO3 is mentioned? 1. So see, 2 moles is producing 3 moles. 1 mole will produce cross multiplication. X into 2 is equal to 3 into 1. If you get any confusion, go with cross multiplication. Then x is equal to 3 by 2, that is equal to 1.5. Without having these basics, you cannot do other chapter questions. Even you will get direct question on the stoichiometric calculations. The main disadvantage is, in stoichiometry several models are there. You cannot expect which question will come, but one question will come, and these all are important for other chapters. So double benefit. You will get direct question, and we use these basics in other chapters also. But one happy thing is, just NEET level only. NEET level means NEET level question only will come in the stoichiometry, not JEE level. JEE level questions are very tough. So if you practice some 10 to 15 models, that is enough. Okay. Completed. Mole relation is okay. No doubt now. Now keep heading. Next category, weight calculation. Mole is our now. Next weight calculations. Keep heading. Weight calculations. One simple example. CaCO3 upon heating gives rise to CaO plus CO2. For any other types of calculations like weight or weight volume, first you should write the mole relation. First of all, tell me how many moles of CaCO3 is present? Is there any number here? No. So you can write 1 mole here. This is also 1 mole. This is also 1 mole. 1 mole, 1 mole. Now use stoichiometry basics. Mole concept basics. 1 mole of any substance weight is equal to its gram molecular weight. That's why I said to learn the basics. 1 mole weight of CaCO3 is 100 grams. 100 grams is producing. Let us take only one. You can take this one also, but let us understand by taking one product. 1 mole of CO2 weight is, what is its gram molecular weight? 44 grams. 44 grams. So this is weight relation. 100 grams of limestone upon heating produce 44 grams. Weight. 100 grams, 44 grams. 50 grams, 22. 25 grams, 11. Weight. For 100, 44. For 50, 22. Half. Weight. For 100, always 44. For 50, half of this value. Like weight. Not done. 100 grams of limestone upon heating produce 44 grams of CO2. Let us take one question. Got it? Wait. Find the weight of Ag produced. Find the weight of Ag produced when 2.76 grams of Ag2CO3 is heated. I given already this equation. Once go to the basics. In the beginning I given Ag2CO3. How Ag2CO3 dissociates?
CO2 plus half.
Ag2CO3 dissociates into 2Ag plus
CO2 plus half.
CO2 plus half water, right? First of all, tell me mole relation. Is it balanced equation only na? 2 silvers, 1 carbon. Yeah, half O2 means how many oxygens? 1. These two will get cancelled. 2 will get cancelled, so 1 oxygen. Like this, 1/2 into 2 means 1. So here 1 oxygen is present. 1 oxygen, 2, 3. Here also 3. So total it is balanced. Okay. Ag2CO3 weight is not given na. That's why I said to learn the basics. What is silver atomic weight? What is silver weight? I mentioned in the basics.
108.
Silver 108. How many silvers we have? 2 silvers. Ag2. Carbon weight is? Carbon 12. Oxygens. How many oxygens we have? 3. 3 means 1 oxygen is 16. 48. So total 10. This is 16. 26. 2, 4, 7. Total 276. 276 grams is producing. See how, why I wrote, just a second, wait. Why I wrote here, what is its mole? 1 mole. Silver moles are 2 moles. Silver moles are 2. Clear? Right. What is the weight of 1 mole of any substance? Is equal to its molecular weight. So 276 grams is producing how many moles of silver? 2 moles. What is the weight of 2 moles of silver? 2 into 1 mole weight? 108. Like that. Clear? So 276 grams is giving 2 into 108. But in the question, what is the weight of Ag2CO3? 2.76. So cross multiplication, 2.76 grams will produce. Say the answer. Do cross multiplication.
2.16.
276 into x is equal to 2 into 108 into 2.76. Okay. X is equal to 2 into 108 into 2.76 divided by 276. See, 276 get cancelled, but here point is there. After point, how many digits are there? 2. So in the denominator, so you can write first like this. If you get any confusion, 276 by 276 into 100. Write like this. Why? After point, how many digits we have? 2. So 2 zeros. 276 cancelled. Now 2 into 108.
216.
216. 216 by 100. Now in the denominator, 2 zeros are there. So 2.16 grams. This is easy or tough question? Do one question. How much weight of? How much weight of? You do this question. How much weight of? Methane should be combusted. Methane should be combusted to get 1.1 grams of CO2. Do by your own. Very easy question, but what is the task in this? You have to write the equation. Combustion means CH4 plus O2. CH4 plus O2 always gives CO2 plus H2O. Combustion reactions are given. Any hydrocarbon when combusted in the presence of air. Combustion means burning in the presence of air. See the solution. CH4 plus O2 gives rise to CO2 plus H2O. You have to write this equation by your own. Okay. And balancing is 2 here and 2 here. Okay. What is the relation? 1 mole. 1 mole is giving 1 mole. Right. 1 mole weight is 1 mole of methane 16 grams. 1 mole of CO2 44 grams. Right. So to get 44 grams of CO2, how much weight you have to take or how much weight should be heated? 16 grams. To get 44 grams of CO2, you should take this much weight of methane. To get 1.1, how much weight of methane should be taken? Do cross multiplication. X into 44 is equal to 16 into 1.1. Upon simplification, how much you will get? This will go 1.1 into 16 divided by 44. We can write like this, 11 by 44 into 10 here. Here you will see here. 1.1 I am right. 1.1 can be written like this now. Remove the point, keep 10 here and 44. Clear? Remove the point and in the denominator write 10. 11 into 4. Next 4 into 4. So 4 by 10. 4 by 10 means 0.4 grams. The volume. Weight volume calculations. CH4 plus O2 gives rise to CO2 plus H2O. Balanced equation 2 here and 2 here. One compound data in terms of weights and another compound data in terms of volume. One. Let us write weight of methane. What is the weight of 1 mole of methane? 16 grams. And oxygen data in terms of volume, liters. See, 2 moles of oxygen means how much volume? 1 mole of any gas occupies how much? 22.4 liter. 2 moles means 2 into 22.4 liter. So 2 into 22.4 liter means 44.8 liters. So how much volume of oxygen is required to combust 16 grams? 44.8 liters of oxygen is required to combust methane. 16 grams of methane. Write that statement. 44.8 liters of O2 is required to combust 16 grams of methane. This is weight volume relation. For 16 grams you need 44.8 liters. Weight volume relation. You note down another two formulas and revise the basics thoroughly. All these are basics only up to today's class. Basics only. I'll give you two formulas by heart. 2 or 3 formulas I'll give you by heart them. Percentage of an element in a compound. Percentage of an element. You can write under note. Percentage of an element in a compound. Important formula is equal to atomicity of that element. Atomicity into atomic weight by molecular weight into 100. For example, CO2. Find the percentage of oxygen. Percentage of oxygen is equal to, what is the formula? Atomicity. How many oxygens we have? 2. 2 into what is atomic weight of oxygen? 16. My total molecular weight is 44 into 100. How much? 16 by 44 into 22 again 8 times and 11. 0.0 7 times 77, remaining is 80 minus 77 is 3. 11 into 2 times, so 0.72. 0.72 into 100 is remaining here, so 70. Approximate value and 72%. Okay, right. Very important basic idea. So before revision starting, especially for you and for you also, okay, we are covering all the basics very slowly. I didn't check you. I hope you learned all the basics. Utilize the program thoroughly, because you just imagine during the revision schedule it is not possible. At least if you learn 3 chapters in physical chemistry, that will be very helpful to you. Because in thermodynamics these basics will come, in ionic equilibrium these basics will come, and in chemical equilibrium these basics will come. Okay, in first year, I am talking about first year physical. In secondary physical, in every chapter, all these basics will come. Okay? What is the percentage of an element in a compound formula? Atomicity into atomic weight by molecular weight. Next, one very important information or very important point. Danger symbol. Note. Whenever you get the question, calculate minimum molecular weight. If you observe this word in the question, minimum molecular weight, find minimum molecular weight, calculate minimum molecular weight, these words, then take atomicity as 1. Take atomicity as 1 in the above formula. Now done, to get a minimum molecular weight, take atomicity as 1. To get minimum molecular weight, you should consider atomicity as 1 in the above formula. In above formula, two more formulas. Percent purity. Next week we'll discuss about this, but you by heart the formula and come. Percent purity is equal to weight of pure compound divided by weight of impure compound into 100. Percent purity. I'll explain what is percent purity and percent yield. Percent yield. Actual yield by theoretical yield. Actual yield by theoretical yield into 100. The next week we'll discuss about this. What is yield, what is actual yield, what is theoretical yield. Okay, before that everyone should thorough in the basics.